Welcome engineers. In this video we are going to do comparison between the single versus a combined substation equipment foundation in Eurocode. So as you see this in the left hand side at top, the picture which is showing a single pedestal isolated shallow foundations which should be used for low voltage like 22 kV or 11 kV 3-phase equipment. We can use this single pedestal isolated foundations. In case of higher voltage you can use for one single isolated pedestal foundation can be used. In the middle you can see the combined foundations which is having a 2 pedestal and 2 structure over the base slab. So this type of foundations is combined foundations. In the right hand side picture, which is a disconnector or isolator having a equipment over the structure, both are mounted on the 2 pedestal or 2 structure foundations. So this we are going to do the comparison between these two now in terms of calculation. In our previous video around 7 stages we have covered the design stages that including for equipment foundations. So in the first we have seen that overview of calculation, second is a foundation and soil parameters, loads and load calculations, 3 stability check, fourth one foundation bolt design, fifth one is a design of a bottom slab punching and one-way shear in sixth, and the seventh is a design of pedestals. So these are all you can see in our previous video. The link for these videos are given in the description. So in the stage as we see that overview of calculations is covered, and stage 2 foundation and soil parameters, loads and load combinations. Stage 3 is a stability check we already done for the isolated foundations, and stage 4 it's a foundation bolt design. Fifth is a design of base slab, and finally the sixth is a punching and one-way shear, and finally the seventh is a design of a pedestal. So these are the things we have seen in our last series of videos for isolated foundations. Now we are not going to detail about the combined foundations, how it is going to come. With respect to the combined foundations, there are some difference we need to make it in isolated foundations. So that points alone we are going to discuss. Generally this will, according to the parameters, there will be some changes, soil and foundation parameters, and stability check also will change according to the formula which is suitable for combined foundations. Design of bottom pad, punching shear, one-way shear, so these are alone will vary. No case this foundation bolt design and seventh one is pedestal foundation will not change. Also the foundation forces which we are going to apply on the equipment foundation will not going to change. Now let me look into that Excel calculation. On the screen you can see that Excel sheet which we have used to calculate the isolated foundations in our previous series of videos. So the content remains same and the introduction also remains same. There is no change with respect to the isolated foundation for combined. Coming to the parameter, that is foundation and soil parameter, there are some slight changes in that. So let me look into that. For combined foundation, that is 2 pole foundations, this picture will change. Whereas in the right hand side you can see another picture that is for single pedestal isolated foundations, and this is our case. Now we are doing the comparison. Coming to this line, this pedestal numbers n is 2 numbers, we have assumed as 2 numbers. Center to center distance, so this is another one important input for combined foundations. Instead of isolated foundations, this entire input is not required as it is a single pedestal. And here the distance between these 2 pedestals, that is C/Cx, is needed here, so that we have assumed as 2 meter. And coming to the depth of foundations, bottom pad thickness, plinth level, all this we can consider the same as individual single pedestal foundations, and grade of concrete, everything we can consider the same. And coming to here, weight of overburden soil and weight of concrete, so anyway this number of capital N, that number of pedestal is increased, so this number we need to multiply with that. And also accordingly, if it is a single pedestal we can go with a square bottom slab, but in this case we cannot go like a square bottom slab. As you can see here, it is a rectangular in plan, so that L should be greater than this C of Cx. That is 3 meter we have considered as a C slash Cx, which is a spacing between the two pedestal is 2 meter we have assumed. Then it should be 3 or somewhat more than the 2 meter. So because of this also the weight of overburden and concrete will increase. So that is a one change here in overburden soil and concrete. Coming to the eccentricity, for maximum eccentricity we know that B by 3 or L by 3 we need to find out, and as the length is going to change as a rectangular foundations we have considered for combined foundations. So L is a 3 meter we have considered, 3 by 3 is a 1 meter. Similar like limiting eccentricity in about x direction need to be changed, different than the individual isolated foundation. Coming to the foundation loads, these foundation loads we are going to consider the same as in isolated foundations for demonstration purpose. Anyway, this is number of pedestal only going to change on the foundations. The load, the entire structure load is going to act in the pedestal only. These values in green color cells are the calculated value or extracted value from the structure design. It is a structure base in one pedestal, so no need to worry about this. Even these load combinations and this ULS and LS, both load combinations are calculated based upon the factors, partial safety factors, and the loads which are going to be combined for these cases respectively. And this value is just multiplication and adding as in isolated foundations. There is no change in this. And coming to the stability check, so here these are the yellow highlighted cells are the changes with respect to the isolated foundations. So that isolated foundations we have considered the loads HX, HY, MX, MY for single pedestal including this VZ. But in this case, as we are going to do with the combined pedestal, that is a two number of pedestals. So here it is mentioned some index which is multiplied with 2. So here if you look into that foundation loads, it is 5 in SLS cases, first cases. So multiply with 2, it is 10. So likewise we need to multiply all this yellow highlighted value into 2. Then this P value also change according to the size of the foundations. Similar like this ULS case also, HX, HY, MX, MY, all this VZ, all this to be multiplied as two numbers. So you can see here in SLS load case it is 6.5 to 5.7, and here 13, 4, 11.4. Directly it should be multiplied by 2, and remaining this overturning check and bearing sliding check also, these changes will impact. Other than that there is no changes. Coming to the foundation bolt, there is no change because we are going to apply the single pedestal forces to the anchor bolt, so that we can able to find out whether the anchor bolt is safe in shear and tension and bond length is sufficient. So this is a general check. This is common to both isolated and combined foundation. Coming to the design of bottom slab, here there is a change. Generally this bottom slab used to have some sagging movement at the base due to the bearing pressure, soil bearing pressure. So when the soil pressure is upward in this kind of foundations, then this soil will bend like this, like sag will happen. It means the bottom area required reinforcement steel, which is subject to more tension compared to top. But in this case, there is a two pedestal we are having. Suppose the soil pressure is like this, in upward direction, then this foundation will have two type of movement directions. One is this side after the support it will go like hogging, that is negative moment. So this is a influence diagram for these foundations due to the upward pressure. So this part, this area, the tension will occur in the top, and this part, the tension will occur in the bottom. So these are the two various of analysis we need to in case of combined foundations. So here what we have done here is, for sag span we need to consider the cantilever span of this distance, because the length minus c of cx, that is a center to center distance of the entire pedestal to pedestal distance, and divided by 2, that is 0.5 meter. And for hog span we need to consider the middle distance, that is a center to center distances. So these are the cantilever span and the mid span for y directions, and for x directions there are only one, that is b, capital B divided by small b divided by 2, which is 0.45. And the next is moment on slab we need to consider. For sag moment, this is equations, the dun is the net pressure, so it's a dun, so that is what we have applied here, into L1 is a 0.5 divided by square. As this part, if you are talking about, these are the cantilever portion and these are the simply supported portion. So we need to apply the bending moment equation as like this. So for cantilever part it is a WL square by 2, where the W is the dnu, delta dnu. So here that simple is missing, I think. So similar like for other case, hogging moment also we need to make it like WL square by 8 equation for simply supported equations, which we used to follow. So here that L square, L is this span we need to consider. Obviously the hogging moment will be higher as the length is more, cantilever length is more, that is overhanging distance is more. So these are the two changes in y directions. In x directions there is no change, because we are going to provide the same single pedestal design concept in x direction, and the reinforcement also will change according to the hogging moment. So these are the two sagging moment in x and y directions, there is no change. These are similar like isolated foundation. And coming to the hogging moment in y directions, the moment which we need to consider is as the moment which is calculated for hogging moment. So this one 22.875 kilonewton meter. So that is one change compared to isolated foundation. And next, coming to the punching shear. In punching shear, this QS value will change because the number of pedestal N, the capital N is going to increase as 2 instead of 1 in isolated foundations. So this will impact. Remaining things are same as like isolated foundation. Also Q also is going to change. Wherever the capital N is coming, in that area it will change. Also this L, capital N, L we are going to consider the maximum length of the foundation base slab. Coming to the one way shear along X and along Y, you can see there are two different way of calculating the one way shear. One is in along X directions, capital B minus small b divided by 2 is the distance of face of the pedestal to from edge of the pad, and here in this case L divided by C slash Cx, that is the spacing between two pedestal divided by 2 is a case, and the critical distance also will change, 0.2 here, 0.25 here, and maximum factored force will also change as the critical section is changing here slightly, and maximum factored shear strength. So here in x direction it is 0.06 megapascal and y direction it is 0.07 megapascal. So there will be two different one way shear output. Coming to the design of pedestal, the calculations and all these parameters remain same as per isolated foundations. And finally the reinforcement detail will be like this. In plan view you can get a complete detail of the reinforcement without reinforcement dimensions, like L equal to 3 meter, B equal to 1.6, small l, small b are 0.7 meter, capital D, that is foundation depth, is 1.5 meter. So these are, we have already assumed the same value will be displayed here, and accordingly the concrete formwork and rework quantity and simplified rebar schedule considering the two number of pedestals. So these are the difference which we have seen. This one Excel calculation is developed in Visual Basic Macro Edition. So this can be used to calculate single isolated foundations and combined two pole and three pole, that is two pedestal or three pedestal equipment foundation design in a single Excel itself, as it is developed in macro. So those informations I will share in next video. Thanks for watching.
Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.